Hi everyone, this is Smriti. I'm welcoming you all to my channel QA Automation Classes. So today we're going to start a new topic called as streams. I have already completed the functional programming sessions. If you have not watched those sessions, I will request you to go and watch those playlists and then come back into these sessions of the streams, because here we are going to use lambdas, right? And we have to use the predicate sometimes and sometimes consumer, right? So if you go through the functional programming videos, you will see I have completed predicate by predicate, function by function, consumer by consumer, and suppliers, right? And now we are going to start with the streams. So what exactly is a stream? Let's see. Let's go to the official documentation site of the stream. Okay, that is the Oracle documentation. Streams in Java. Okay, so this is streams in Java. We want to go to the Oracle. Yes. Okay, so let's see. So the stream is introduced in java.util. Okay, if the package you want to understand the package, this is the java.util. So let's go to the overview and see. Okay, so if you see here java.util dot stream. Okay, classes to support the functional style operation on the streams of the element, such as map, reduce, transformation on the collections. Okay, so as the definition says, we are going to use the functional style of the operation on the stream of the elements. Okay, so what is the stream of the element? We'll shortly understand all those things. Okay, so just now understand it, the stream is available in the java.util.stream package. Okay, and this is the package. Let's go to the class. Okay, so if you see java.util.stream, the interface stream. Okay, so let's understand the properties of the streams. Okay, so as we know, it allows the functional style of the development or the operation on the group of element called as the collection. So to store the group of the object, we use the collection. Everyone knows that, right? And then after storing the object into the collection, we have to process them. How we are going to process them? We are going to use the streams there, right? So to sum it up, you can say the stream will take the collection as the input. Okay, and then it will filter or map or reduce the data based on the condition, whatever the condition user is providing on top of those streams. Depending upon that, it will do the specific operation, and then we can print them or we can store them and store them to a different collection type of element. Okay, so if you see, the stream will never ever going to update the original collection. So we have a original collection, you do some filter or map or whatever operation you do, it's not going to change our original collection. Our original collection, what was there, it will be there forever. Okay, and there are two different ways to do this. One is called the filter and map. There are few other methods also we'll be discussing. Okay, and this stream is lazy in nature. Okay, it evaluates the code whenever it is required. Okay, so and in this stream concept, we have two concepts. One is the terminal operation, another is the non-terminal operation. Okay, so what exactly is the terminal operation and what exactly is a non-terminal operation? So terminal operations are nothing but the processing operations. Okay, non-processing operation. So non-terminal operations are called as the processing operations, and terminal operations are called as the operation which will terminate, right? After that, you cannot do any further processing. Okay, so if I'm confusing, I'll give you an example. Okay, so now let's say I have listed out the list of the non-terminal and the terminal operations. Okay, so we have, I can show you. Okay, so let's say we have the collection. So this is nothing but the collection. I'll say we have the collection. On top of the collection, we will use the stream method. Okay, so which method we are going to use? We are going to use the stream method. So after using the stream method, we can, on top of this, we can use the then on the stream method, we can go ahead, we can use the processing or non-terminal methods. Okay, so these are nothing but the processing or non-terminal methods. Okay, so what is this processing or non-terminal methods? I told you already. So non-terminal methods are the methods which doesn't terminate the enter processing, so that we can again continue with the some more operation. And after the processing or non-terminal function is applied, on top of that we can apply the terminal functions. Okay, so this is what is the flow. Okay, hope you guys are clear. So what we do, we have the collections. Okay, on the collection we apply the stream method. After applying the stream method, we apply the processing or the non-terminal methods, and on top of that we apply the terminal method. After applying this one, either we collect the resultant data in the form of the another collection, or we just print them. Okay, so we'll see that. Okay, so if you want to understand what is the non-terminal or the processing operations or the methods we have the non-terminal operations like let me expand this one. Okay, so we have filter, we have map, we have flat map, we have distinct, we have limit, we have pick. Okay, these are non-terminal operations what we have in the stream. And for terminal we have other methods like any match, all match, okay, and non-match, collect, count, find any, find first, for each, and mean, max, reduce to array. So we are going to cover all of them, all the non-terminal operation and all the terminal operations in the upcoming sessions. Okay, so we'll give the actual examples where you can go and see how the non-terminal operation is being applied and how the terminal operation is applied. Okay, on the stream. So as I told you, we have the different types of the methods to be applied, right? One is, let's discuss about these two things in the brief. Okay, filter and the map. What is filter? So filter is nothing but what you can say, based on the some condition we are going to filter the original collection. Okay, and then we are going to store those details in another collection, or again we can use that result for the any further processing also. Okay, so uh, I can give an example here. Okay, so okay, so let's say I have a array. Okay, so array contains few elements. Let's say 1, 2, 3, okay, 4, 5, 6. Okay, so these many elements are there in array. So now I want to apply the filter. So but what is my condition, how I want to filter this original array of data? So I am going to say, okay, from this array give me the list of all even numbers. So if I want to get the list of all even numbers, I'll get 2, I'll get 4, I'll get 6. So these 2, 4 and 6 is a my desired output that I want to get. So here if you see, we applied the filter function and we got the result 2, 4 and 6. So this, if you see, these 2, 4, 6 are nothing but the only 3 element. Compared to this 6 element, we got the 3 element. So if you see, the data is reduced here. Okay, so depending upon the filter condition, the data may or may not reduce. Okay, similarly we can say, suppose we have the list of the strings, right? Let's say hi, one more is hello. Okay, and third one is world. Okay, so let's say we have a few strings like that. Okay, and let's say hey. Okay, so let's say we have these 3 4 strings. I will say give me all the strings whose length is greater than 4. Okay, so if length is greater than 4, here it is 2, so it will not come, and here it is 3, it will not come. These are 1 2 3 4 5, 1 2 3 4 5. So definitely hello and world will be coming, right? So this is another example of the filter. So out of those 4 elements, we got only 2 element. Based on our condition, we filter hello and world. Okay, so this is the filter. Then also we have the map. So what is this map? So map is nothing but you, as the name says, we are going to map it, right? For each element we are going to map it into the some other element. So let's take this same example, 1 2 3 4 5 6, whatever we have. Okay, so now Okay, so out of this, let's say, okay, 1 2 3 4 5. Okay, so we are going to map each element to its respective square. Okay, so that means one. So instead of having this, so for each element we are going to find the square of the each element. So how we are going to find? So 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, right? And then 5 square is 25, and 6 square is 36. So this is nothing but my expectation now. After applying the map, I want square of the each number. So here if you see, I will get square of the each numbers. This can be achieved through the map. Okay, so these numbers I can achieve this with the help of the map. Okay, so this is not nothing but the map. So I already told about the other methods, right? So like filter, map, flat map, distinct, limit, right? Terminal operation, we have count, mean, max, any match, all match, right? Collect, right? So we're going to see all those examples. Okay, so that's all about introduction to the stream. So next session will be starting with the filter method to understand how exactly we are writing the code, how exactly we declare a collection, and on top of it how exactly we apply the stream method, and how with the help of the lambda we then how with the help of the lambda how we get our desired output, or we filter, right, depending upon the condition, and then how we collect those results, right? So whatever the results you see here, how we collect them and store it, or how we directly display them, that's what we are going to see. Okay, so thank you everyone for listening to the session and watching this video. If you really like this video, please do subscribe to my channel, like and share among your friends. Okay, so thank you everyone, bye.